often wondered about the power of nature, its monumental energy and its colossal force exhibiting itself in natural disasters. I'm appalled as Hiroshima and Nagasaki remind me that even disasters man-made find their power sourced within nature itself. Mankind could dare split the atom with such disastrous consequences only because atoms and molecules have a benign presence around us, till it is so hazardously unlocked. It is only when I confront nature's beauty that I begin to see the riddle that human civilization has so long tried to solve. Atoms and molecules are after all in the structure of the very elements with which our universe and we ourselves are constructed. My observation of the endless domain of science brought me to study physics. I knew that the Shah Institute of Nuclear Physics in Kolkata was a premier center of learning, so I wrote to its director. I was accepted, and my excitement brought me to the Shah Institute a day before my course began. India's first center for nuclear physics. It was established by the great Indian pathfinder Meghnad Saha. A visionary, he paved the way for so many much greater than me. I was lucky to have a chance meeting with the director himself.
Welcome to Shah Institute of Nuclear Physics. Please give it to the Abasan security.
Okay, sir.
Sampurna, I understand your class starts tomorrow.
Yes, sir, but I couldn't resist myself. Sir, could I look around and see the premises?
Of course, you are part of this institute. You are free to visit any laboratory you like.
Thank you, sir.
But you should also know the history of this institute. You know, Professor Meghnad Saha is a celebrated physicist, well known throughout the world. In fact, he was the first person who started nuclear physics in a MSc course in a university in India. That's the Calcutta University.
Soon after India won freedom, the foundation stone of the institute was laid by Dr. Shyama Prasad Mukherjee, Union Industry Minister, on the 21st of April 1948. The primary target was to build India's first cyclotron and to inaugurate research in nuclear energy. Meghnad Saha passed away on the 16th of February 1956. After that, it was renamed the Shah Institute of Nuclear Physics. The Shah Institute of Nuclear Physics shifted from Raja Bazar to its new Bidhannagar campus in 1989. The Shah Institute of Nuclear Physics today has diversified into different branches of science, classified into 5 subjects. Specialized centers include facilities for research in experimental nuclear and astrophysics, or FRENA, the Center for Nanoscience and Surface Physics, or CENSUP, the Center for Applied Mathematics and Computational Science, or CAMCS, and the Center for Astroparticle Physics, or CAP.
You know, now a lot of activities, research activities is being done in nanoscience. What is nanoscience? Nanoscience is actually...
This laboratory was started with a setup to probe the shape and structure of surfaces, interfaces and films by scattering X-ray from the samples at very low angles. The other instrument, a scanning probe microscope, could see almost the atoms on a surface by measuring the force these exert on an extremely fine tip as it is moved over the surface.
Nd:YAG laser, that's what we use.
Laser flash photolysis helps to identify the transients formed during the interactions between different chemical and biological molecules.
A whole new world opened out before me at the library of the Shah Institute. Books and journals lead me to look for other sources of information available not just in the ambience of the library alone, but also far beyond. Unknown doors of perception open out for me here as I reach out towards horizons I did not know existed.
New horizons are being discovered and nurtured at the Shah Institute beyond nuclear physics. One of the new disciplines is econophysics. The 11th Five-Year Plan project has contributed the Cray XT5 supercomputer. The XT5 has a two-cabinet configuration comprising of 172 compute nodes, each node having two quad-core processors providing 1,376 compute cores in total. This laboratory is equipped with inductively coupled plasma mass spectrometer, which can measure ultra-trace amount of any element down to parts per trillion level. The Large Hadron Collider in CERN, Geneva, has scientists from the Shah Institute of Nuclear Physics. Work on the search for dark matter candidates has also been initiated in collaboration with the Picasso experiment stationed at the Sudbury Neutrino Observatory or SNOLAB in Canada. Scientists of the Shah Institute of Nuclear Physics have been an active partner in the design and fabrication of large numbers of detectors in the Indian National Gamma Array Project or INGA. Research in nuclear physics also covers a broad range of nuclear structure and reaction studies spanning a very rich nuclear landscape of stable and unstable nuclei.
My life at the Institute engages my mind and my attention constantly. But of course, that does not mean all work and no play. The presence of lively minds among my fellow students makes living here a totally different experience.
Inspiration at the Shah Institute extends even to the well-equipped workshop, where students are expected to participate in projects headed by leading members of the illustrious faculty. The wide array of equipment and the variety of ongoing projects offer a significant gamut of learning opportunities.
An invitation from a friend to a lecture at the auditorium can open new windows into the world of science. My friend's invitation turned out to a thrilling experience to listen to the lecture of Professor C.N.R. Rao, the world-renowned material scientist and the former director of Indian Institute of Science, Bangalore. Next door at the auditorium complex is the Science Gallery, a permanent exhibition into many areas of science and scientific research. Life at the Institute offered another dimension in the hostel ambience shared by so many bright and lively students. I realized early enough that the exacting demands of a scientific career would drive us to our books even in the few hours of leisure to prepare ourselves for the next day.
The metallic system, and then subsequently we will discuss both sides.
The post-MSc Associateship course in physics was launched to train bright and strongly motivated young students with master's degrees in physics from Indian universities. The objective of this laboratory is to develop quality human resources for the advanced R&D projects with specific job assurance for the best, and to attract and educate very bright students into fundamental research through a series of courses, seminars, workshops and exchange programs.
I was excited on my way to the photoemission spectroscopy laboratory.
The ARPES laboratory provides state-of-the-art facilities with angle-resolved photoemission spectrometer acquired recently by the Institute. It performs surface electronic structure characterization of crystalline materials. Another laboratory houses the experimental setup used to characterize the magnetic materials at very low temperature with the application of a magnetic field low enough. Secondary ion mass spectrometry or SIMS is a sensitive analytical technique capable of detecting any element or compound present in a surface layer at less than 1 parts per billion concentration. The liquid helium plant and the liquid nitrogen plant are included in one of the oldest cryogenic facilities in the country, where inert gases like nitrogen and more recently helium is liquefied. This is one of the earliest nuclear magnetic resonance laboratories in the country.
My exposure to interdisciplinary scientific inquiry has led me to many laboratories inside Saha Institute of Nuclear Physics, like the Molecular Biology Laboratory.
Subtle disturbances in the activities of the normal molecular players that can transform them into veritable rogues are studied at the laboratory. The rogues are manifested in severely debilitating hematological disorders like thalassemia, sickle cell anemia, leukemia, or neurodegenerative diseases like Alzheimer's, prion, Parkinson's, or Huntington's. The tools of modern biology enable the visualization of the interior of a protein molecule. Despite its huge size, the first Indian electron microscope was fabricated and built at the Saha Institute of Nuclear Physics during its early years. The transmission electron microscope is the most powerful tool and is used to characterize nano-sized materials. Plasma, the fourth state of matter, has immense potential for applications. The major application is to generate energy through nuclear fusion in a tokamak. The Saha Institute of Nuclear Physics has an efficient administrative system, spearheaded by the Registrar's Office and the Accounts Department, to name a few, that supports the academic ambience of the institute. The medical unit is always on the alert to provide support to students and employees. Meghnad Saha's pioneering work on thermal ionization opened up several new frontiers of astrophysics. Today the institute has a new optical telescope housed inside an observatory dome. It opens up a new window to the fascinating universe for students and researchers. Named after Meghnad Saha, the observatory is a humble tribute to the founder of this institute on the occasion of the Diamond Jubilee year of the institute that bears his name and carries on his life's work.
Nature has come to mean much more to me than it did before. Its power synonymous with its glory, its potential for service to mankind more important than its potential for destruction. I have come face to face with the ethics that must govern science and all scientific activity.